Ryan Anger, Vice President and Program Director for Bell's Future Long-Range Assault Aircraft, the V-280 Valor. I'm here today with a panel of Master Aviators, 154 combined years of service and 22,000 flight hours. It's going to be a great discussion talking about future vertical lift and the future long-range assault aircraft. If I could please have you gentlemen introduce yourselves, starting with Jay.
Sure, Ryan. I'm CWB-5 retired blank, and I'm Senior Government Relations Manager with Bell, concerned primarily with sustainment. So former maintenance test pilot, started out in UH-1s, then transferred over to AH-1s, and then went into the Apache, flew A-model and D-model Apaches.
I'm a retired CWB-5 Randy Garrett. I am the Mission Effectiveness Lead within Survivability at Bell. Retired after 30 years in the Army. I flew UH-1s, UH-60s, pretty much every variant, instructor pilot, maintenance test pilot, maintenance examiner, safety officer.
Hi, I'm Terry Horner, Government Relations Director at Bell and retired CW-5. My experience is in standardization and instructor training, and then I've flown Kyle Warriors, Blackhawks, Mike and HH Mike, and Apache, Delta, and Echo operationally in the Army.
CW-5 retired Doug England, just retired a year ago, working for Bell. Fort Campbell representative, mostly in the sales and strategy side. Background started as enlisted. I was a technical inspector, airframe and power plant mechanic, and A&P mechanic. And then went to flight school, flew mostly Chinooks, but rated in about 10 different aircraft, 3 different Bell products, both on the civilian and the commercial and the military side. But mostly from the weapons tactics instructor side, senior instructor pilot side. That's kind of my background. It's more of a standardization and very operational.
I'm CW-5 retired Scott Verswalis. I do survivability with Bell, particularly do kinetic vulnerability reduction. Qualified in the UH-1, OH-58 Alpha Charlie Delta. I flew the OH-58E Kyle Warrior for 20 plus years until the Army divested that out of the inventory. Qualified in the U-860A LM, flown Ls and Ms operationally as well as the 58D, and I'm qualified in the C-12 as well.
Thanks, Scott. So clearly a lot of depth and breadth of experience on the panel. We've got survivability, maintenance, training, operational experience. The Black Hawk first flew its prototype in 1974, so it's been a long time. It's been a great air assault platform for the Army. The Army's talked a lot about the need for transformation and having a new capability in 2030. So let me ask Terry, when you hear future long-range assault aircraft, and with your experience, what does that mean to you?
It means a transformational capability to the Army. It really means a really leap forward in what the operational force gets with modernizing its aviation force. If you think back to those early Blackhawks and even today's Blackhawks, you've gained about 20 to 30 knots of airspeed and a passenger in 60 years since the first Huey started flying operational. And what you get with FVL is you get double the speed and double the range with about another 40% of lifting payload.
How do you think the Army is going to be able to adapt to that increase in capability?
They'll adapt to it in the same manner they adapted to the Apache and the Blackhawk when they came into the fleet. I mean, at one point the Army flew H-1 Cobras, H-1 Huey Iroquois, and the fleet and the force adapted rapidly, learned new tactics, techniques, and procedures based on the capability of the weapon systems they were operating.
One of the biggest differences, I think, going from a Black Hawk to a future vertical lift Flora aircraft is going to be speed. Randy, what do you think about the speed advantage going from something that is 140 knots to something 280 knots or more?
Right, so I think speed is so important to all the equations on the military. It gives you the range you want, it enhances survivability, and it reduces the amount of flight time for any given mission, which hopefully in the long term is going to reduce costs as well.
And Doug, over 2,500 missions flown, what do you think about in terms of range and speed?
Well, if we can't make something that goes faster, much faster than our current fleet, then why build it? Mm-hmm. Because it's operational reach. So there's things that we need to develop to give the Army that comparative advantage. And comparative advantage is operational reach, and that's how you buy down risk. And so commanders out there, need that capability gap filled, sometimes it's time, sometimes it's range, but it's all gained by the nature of speed. So speed and added fuel, then everything else will fall in line.
Okay, thanks, Doug.
You know, Ryan, speed also allows the operational commander to get inside of the decision cycle of an adversary that they can't get inside of right now. And the ability to create dilemmas for an adversary is one of the things that makes our Army so successful on the battlefield. So that speed gives our Army the opportunity to even further get inside of a decision cycle of an adversary.
You know, at Bell with the V280, we focused a lot on speed because it's a tilt rotor configuration. It's flight proven. We've got 600,000 hours in combat on similar configurations. It's well understood. We get speed very efficiently. We get range very efficiently, but we can't forget about the low speed operation of the aircraft and in and around the landing zone. Doug, do you want to talk about that at all?
So the maneuverability that we have in the objective area, I won't even speak of the X because the X is a slang. It's something that is based on a distance. That let's go to the graduate level. Let's go to the things that we need to do when we're in the objective area, whether we're close or we're far away. With today's technology and the way the Bell's history of tilt rotor and the advanced technologies, I challenge the ability to do the things that we do with the current fleet, whether it be a Chinook, a Black Hawk, and other aircraft for maneuverability. I think when you look at experimental test flights documentaries, they will say that maneuverability is there now today, but it will be better in any airframe that we build that's ground up. So that concern was quickly negated because the things that we need to do, the V280 and the 360 will be able to maneuver. So that has become such less of a concern that we need to not focus on because it's solved.
Yeah.
It's done.
And you know, honestly, whatever future vertical lift aircraft the Army selects will have the low speed agility that's required by the Army, or they won't make it through the selection process to be the next aircraft for the Army.
No, agreed. Well, I want to get back to training here in a second. Before we do, though, Randy, you spent a lot of time in our simulator providing feedback to the engineers to help ensure that this aircraft would do what it needs to do for the Army at low speed and high speed. So how critical was it for you as you provided that feedback to the engineering team on how the aircraft behaves at the objective?
Yeah, so it was pretty amazing to get to do that and to interact with those folks. And to my first experience getting in there, being a helicopter guy my entire career, I was extremely impressed, both with the up and away high-speed maneuverability of the aircraft, as well as the low-speed handling qualities that allowed me to do everything I wanted to do in a Black Hawk. I would argue even then plus some.
I agree.
When we talk about the operation at the objective, when we talk about range and speed getting to the objective, we've got to also talk about survivability, right? That's going to be a critical aspect of the airframe as we look to the future and peer and near peer, threats. Scott, do you want to talk about survivability at all?
Yeah, kind of dovetail on what Randy said, talking about survivability, and I think speed kind of equates into exposure time. When you look at the time it takes for an adversary to use a certain weapon system, that equates to feet per second as you're moving through their engagement area, and we're cutting that time in half. We're cutting the time over in half from the RPM bound to get on the ground compared to the speed we're flying today. So the big thing is that exposure time, and then going to the mission effectiveness, doing the mission planning, using the terrain and the vegetation to mitigate the enemy to be able to acquire you and shoot you, and then be able to get into the weapon engagement zone, get on the ground, and then use that speed to get out of the weapon engagement zone is just key. It's critical.
So the different technologies also probably have something to do with if you aren't able to evade the threat and you do take a hit from something. Can you talk about the technologies in the aircraft that help us to survive?
So when you talk about survivability as a whole, really, we kind of have two things: susceptibility and vulnerability. Susceptibility is trying not to get shot, and vulnerability is if the aircraft is shot, what's the graceful degradation of those systems on board the aircraft. So from a susceptibility side, we're integrating all the systems, aircraft survivability equipment to be able to provide threat warning. And then from a vulnerability standpoint, kind of building in lessons learned from V-22 We've done ballistic testing since then to inform design, so really that data-driven innovation to look both at are we ballistically tolerant on our critical systems so we can maintain safe flight and landing to get aircraft back to a safe location to repair, and as well as looking at reducing weight. So in fact, right now we're in the middle of a test where we're looking at 2 different rib designs. One design would actually make the aircraft lighter, but we want to make sure that that has the same ballistic tolerance as a standard type rib in that aircraft.
Okay.
And that whole wing design for V280 is really ballistically tested. The skin, the spars, the ribs, all that. And that'll just culminate in actually one test in the end, a full 5-bay production representative wing that will test under load to make sure it's still survivable.
Okay.
If I could add to that, Ryan, too, on the survivability aspect, I think one of the big, he mentioned the wing, in addition to the ballistic capabilities of the wing, what that wing brings you as well is that single engine window. So in most multi-engine aircraft, we're not overly concerned with dual engine failure. It's that, hey, I get an engine shot, whatever, that I'm gonna lose that single engine. The single engine window for this aircraft is so much larger than we've ever had in any rotary wing aircraft. And that's an extremely enhancing capability.
Absolutely. The ability to fly away when you lose an engine versus you're going to the ground because you don't have the flyaway capability without the lift off the wing. And then I think about, all vertical lift aircraft, they all are susceptible to vortex ring state or settling with power, however you want to say it. They're both the same thing, essentially. And every aircraft that flies vertically has that susceptibility. But the one thing that I've noticed flying the simulator repeatedly is that you can get out of it so much faster with the pylon over wing configuration. That pylon over wing configuration allows you to roll the pylons down as fast as the window will allow you up to 8 degrees per second. And that allows you to do what Randy said, get on that wing, get out of the situation you're in.
That's extremely important in a long-range mission.
Yes.
So if I lose that engine deep in bad guy territory, I got to be able to get home.
So we've survived the threat, and now we've brought the aircraft back, Jay, and it's got some holes in it. And we've got an airframe that's a combination of metallic and composites. Composites where it makes sense, and metallics, where we can use metallics and maintain affordability and lightweight. So repairability after damage, what are your thoughts on that?
A couple of things on that. The future vertical lift and just modern aircraft now are taking us to lightweight aircraft. Weight is everything when you're talking about range. And there are some folks that are concerned, well, now we're moving from, we've had primarily metal-based aircraft, and what does composite bring? So, I think composites are a real opportunity in terms of aircraft design, but the other thing is they're not something we need to be concerned about. They're something that we need to be able to take advantage of. Battle damage repair on composites can be accomplished in the field. We've established that. The V-22 composite aircraft, it's taken plenty of hits, and we've figured that out. So I see it as something in the future that, we're going to do things a little bit differently, but we're going to be able to do them forward. We're going to be able to do them quickly, get the aircraft back into the fight.
To put that in perspective, too, this is unit level repair, too. Right. And so they're already teaching that trade at Fort Eustis. And so it's nothing that's unfamiliar to the Army. And so just more composite just means more maybe raw material. That an SSA, a supply support activity, downrange, if it's a mature environment, they will have those materials, and it could reduce downtime. But I do want to put that on the operational side, that reliability is everything. So if you are conducting those long-range missions, and you just now extend your operational reach well beyond your support line of effort, then reliability is everything. So that single engine capability, that's really baked in the design of our airframes that we're building. That is the key. If it has a low reliability rate or such complexity, then commanders are not going to use it. The commanders are going to then go something that's known, that's tried and true, and that's reliable. So reliability, I think, does then move further up on the chain for decision making.
Agreed. Jay?
And, we've done some other things with the aircraft too. Scott was talking about, reacting to if you're in a position where the aircraft has taken some damage, where does that leave you? And just one thing that pops to mind is, the power generation on the aircraft in terms of electrical power. We now have the capability to unload some of those crew duties. So if you're in a high stress environment where the aircraft has taken a hit, the electrical system can recognize its own faults, and it's executing the procedures and shedding loads the way it needs to protect critical systems without that crew intervention. So the crew can concentrate on flying the aircraft and doing what they need to do, while the aircraft systems are programmed to look in split second, look at what's happened, give you the best options, and execute those options, all like that.
Let's shift to training for a minute, and I want to talk a little bit about training for the aviator and then also training for the maintainer. We've got an aircraft now that is faster. It's a different configuration than the helicopters that the Army has been flying. It flies like an airplane or a turboprop at high speed. It flies like a helicopter at low speed, takes off and lands vertically. Terry, does a Army aviator have to have helicopter training and fixed wing training to fly a tilt rotor? What are your thoughts on that?
So I have flown this simulator numerous times. I've learned to fly multiple different aircraft. There's a learning curve no matter what aircraft you learn how to fly new. You're going to have to get some training in that aircraft. I think that one of the things that is often misunderstood or misspoken is that none of the services do training exactly the same way. And the Army has two options: maintain their training the way they do it now, and then train those aspects of the future vertical lift aircraft in a different location or just through flying to different spots and doing the landings. The other thing is they can totally revolutionize how they're training. There's an opportunity to completely change how they do training, not have to, but an opportunity. Right now, the Army generally trains pilots the same way they trained them in the 1960s. The general flow of training is exactly the same. And not to say it's bad, it's been very successful, but there's an opportunity to look at how we train the force and take advantage of future vertical lift as an opportunity to improve how you train the force.
Okay, thanks, Terry. And on the maintenance side, it's a different aircraft. We've got electronic circuit breakers. We've got triplex fly-by-wire systems, triplex hydraulic, triplex electrical. It's all built on the digital thread and with digital models. Jay, can you talk about how maintenance and maintainers will be trained using this technology on the digital thread?
So digital thread really offers us a lot of opportunities, and for those that aren't familiar with the term, I kind of think of digital thread as starting from that design process where we've designed the aircraft in a digital environment, and then carrying that information all the way through design, assembly, and sustainment of the airframe out there in the field. And it enables all along that loop of from sustainer back to the engineer. So what can we do with that? Well, we can do things like bring that 3D environment to our IATMs. We can bring 3D environment and create virtual reality and augmented reality scenarios that really allow maintainers and pilots to holistically understand the aircraft. There's nothing better than a picture, and when you can bring very high quality pictures into play with kinematics and everything else, explaining to pilots how things work and maintainers, it's a huge boost. You have to see it. Seeing it is believing, and bringing that kind of stuff to bear is huge.
Go ahead, Scott.
And a good example of that's the VR lab. So we're already doing all the things Jay's saying. So now it's really how do we transition that into Army training, but to see how the aircraft is put together. We're looking at how does the part come in and out. Are there any friction points that highlights those things? So it's aiding our design, making it easier to maintain. And then very easily, we just take that digital thread in the VR lab, translate that into training, and fairly easy. The Army has a good augmented reality or virtual reality training device to do all that stuff.
I think the digital thread has allowed us to design the aircraft how we want to build it and maintain it is key to highlight. But we're not designing this aircraft or building it for high time mechanics to work on it. The Army hires apprentice 18, 19-year-old young men and women that want to serve their country. They hire them to work on these aircraft, and we have to have an aircraft that's as easy to maintain as the aircraft are today. And so I think what Jay and Scott just highlighted is the fact that they don't have to change what kind of person they hire or that joins the military to work or fly on these aircraft. And
Terry brings up a good point. You know, one of the things that Bell does is actually at the design process, we have maintainers sitting in the room with the engineers. So why do we do that? Well, we do that because we know however that aircraft gets designed for the next 40 years, that's the layout of the aircraft. Well, if we have a maintainer and they were sitting next to the engineer and says, hey, if you locate said piece of equipment, access panel, you name it, if you locate it there and I have to service that and I have to get something else out of the way in order to make that happen, that's going to be a problem for the next 40 years. So we bring them in and we allow them, we encourage them to help guide us through that process. So again, being able to work in that digital environment, we actually have crew chiefs go in and remove components in a digital environment. Why do we do that? Make sure that the openings are big enough. Make sure we can get in there, that we can turn and remove said components. So all that's enabled with this digital thread. And it's important to hear from the folks that are going to be out there on the line making it happen for the next 40 years. We have that information now.
And back to the aircraft design, if we design the aircraft where things fail less, there's less maintenance to do. And one of the inherent advantages of the tilt rotor concept is reduction in vibration, especially at cruise. Helicopters inherently high vibration, and that is one of the largest drivers in maintenance is vibration, both from avionics, seals, and you name it. The ability to reduce the rotors to 80%, be on wing, and reduce that vibration for the majority of the flight is absolutely going to decrease the amount of failures we have in components.
No, that's a great point. So the V-22 has over 600,000 hours. It's a first generation, tilt rotor technology. It was first flown in the 1980s, very successful at this point, one of the safest aircraft out there. We leveraged a lot of those lessons learned in the V-280 design, which was a clean sheet design for the Army Air Assault mission. What are your thoughts on the Army launching off into an acquisition program with a new technology?
I had a unique opportunity to train at least 100 aviators, flew other airframes into another airframe with a lot of negative habit transfer. So it is easier to train a new aviator who's never flown anything to fly something new than it is to try to teach an old aviator new tricks. So with the unique experience that I have witnessed and have been firsthand, was the design of being on wing at high speed is so much easier to teach than it is to teach somebody how to hover and maneuver at low speeds. So having fixed wing experience and actually have some V-22, all 4 hours of experience in an MV-22, the first hour I picked it up quickly. So I realized then from a trainability standpoint that there's going to be a transition period for many, many years for the Army. So it is the high speed regime is where the training is, where the gap where the Army will culturally adapt to, but it'll be very quick. Regardless of the design of any airframe that the Army will adopt, high speed is going to be something and high altitude is going to be something that's a cultural change for the Army. But you don't, it is our best interest right now to make sure all data and learning points are available, so then the Army can make a decision on how they're going to train it.
I'm glad you mentioned that real quick. You were an inductee into the Army Aviation Hall of Fame. For that next generation of Army pilots that hasn't even touched a cyclic or anything yet, what would you tell them knowing that future vertical lift might be their first platform?
I'm excited for them. I'm truly excited for them. My son flies Blackhawks for a National Guard unit. And the control laws that exist today is what is distracting for mission management. Mission manager is going to be the hierarchy of aviators of the future, because the control laws and maneuverability aircraft is going to be there, and it's going to be so simple to the person to maneuver that aircraft that will be less distracting, so we can become more mission managers. The future aviators will be able to then be a force multiplier on the battlefield. So I'm excited for them, and today's technology is in their fingertips right now, and it's going to be at their fingertips with future vertical lift. So I'm very excited. So I've heard it many, many times that today is going to be the slowest advancement of technology that we'll ever experience in our lives. Tomorrow is going to be exponentially greater.
Yeah, I agree with you. I think that the young Americans that are going to, or men and women that join the service to fly, I wish I could go back 20 years and be on the cusp of future vertical lift right now, because it's going to be fantastic. I think about how we trained the force from flying D model Chinooks to F model Chinooks, and using the flight management computer to do coupled landings, and I watched the senior warrant officers inside of the formation take a capability that they were trained to do, bring it in and let the computer do the landing, to doing a coupled approach with a pilot on the controls, and turn it into a very tactical approach that allowed him to stay on glide path to the landing all the way to the ground, and get down faster than what they were doing using the system by itself. And I think about what this means to the CW2, CW3 inside of our companies right now, and watching them adapt the tactics, techniques, and procedures to the capability versus trying to adapt a capability to the tactics, technique, and procedure. I think that's one thing that we're overlooking right now, is we're trying to fit the future capability into the current tactics box and the current doctrine box, and it's going to give you more.
It's interesting. I mean, we've talked about air vehicle performance and speed and range, and doubling some of those capabilities. One thing we haven't talked about is the open systems architecture. So having an open system is something that has been critical for the Army to allow them to upgrade at the speed of technology and overcome obsolescence issues. Randy, how important is it to have an open systems approach, open systems architecture that allows for these mission systems upgrades for the Army?
Yeah, I think it's extremely important. After spending 6 years in special operations integration and acquisition in their element called SIMO, that aircraft had lots of sensors, lots of add-on mission equipment, and to add any piece or to replace any piece, the challenge of getting that on board, getting that qualified, getting that ready for crews to go execute in combat was a long process. So anything we can do to enhance that and be able to keep up with the technology as the technology changes will absolutely be needed for the future fight. If we can't stay ahead of our adversary, then we're not going to be in the competition.
Yeah, we can't talk about mission systems without talking about ASE. Scott, any thoughts on survivability equipment?
One of the challenges, right now, how do we take the current, government first equipment, integrate it optimally, make sure you're looking at drag, see how that affects performance, making sure our countermeasures are integrated properly so that they're dispensed at the right angles and azimuths, both for IR countermeasures and RF countermeasures, because all that does matter. Mm-hmm. So actually we're doing some CFD analysis on FARA, to make sure that our azimuth and angles for flares are optimal, that the chaff that's coming off is going to bloom appropriately, just to make sure that's all optimized. Okay. For the platform.
Doug, you've got a lot of experience as well in some of these areas. How do you see technology helping out the survivability aspects of the
So if you put yourself into an Army acquisition officer's frame of mind, it's cost, schedule, and performance. Cost being the #1 driver. And some of that is integration. So flight test qualification or flight qualification testing of new equipment. New equipment is always on the horizon, whether it's industry-based or it's going to be mission analysis gave a critical gap that's within the Army, it's identified. So there's always technology requirement needs out there, but how expensive is it? And really the integration piece and the testing is really the large cost driver for other than the technology that's in the box itself. And look at the Army when they entered into Afghanistan and Iraq in 2001 and in 2003 and just shortly after that, the survivability gap that was there and the acquisition catch-up plan was so expensive and the integration was so timely that the Army had a significant disadvantage in that environment because of the mission open system architecture. And so if you can put it in the system early and the aircraft is agnostic to what is being attached to it, we are light years ahead than we were 10 years ago.
Yeah, to Doug's point, the vendor lock is one problem you have, but to Randy's point, it's you eliminate two problems with MOSA. One, you get away from the vendor lock. Two, you have everything set up. You're just reoccupying that same space. We're not bolting on some federated system that's going to require folks like SRD to have to go through and qualify and do all kinds of extra stuff. You're occupying same space. You're speaking same language. That's huge, and it does come down to money. You can come up with great solutions, but if the budget doesn't support it, your great idea is going to sit on a shelf somewhere. So integration, the ability to not add a whole lot of weight to the aircraft, and avoiding that vendor lock.
I think the ability to get the right information to the mission equipment companies that build the solutions of tomorrow, getting them the code and the interface so they can build native mission equipment versus what we have today, and you'll take LRUs, line replaceable units off the aircraft, which will give you margin back to the crew, or payload back, or fuel back, wherever the Army wants to use it. And then you'll also see the ability of those mission system companies to innovate and bring better solutions to our service members as they go to do operational missions around the world.
So interoperability amongst the services in JADO, or Joint All-Domain Operations, and then the Army's multi-domain operations piece of that. Terry, how critical is some of this upgradability of these systems to future interoperability in a JADO environment?
Yeah, I think you have to be able to communicate across the services and across and with allies. That's where I first think is communication, right? So Joint All Domains Command and Control is one of the first spots that we have to be able. So the network has to be connected, and the aircraft has to be able to use those waveforms or signals in order to get the information to the crew, but also get the information to the assaulting force that's in the back on the way to the objective. And that's just one more aspect of FVL that I think is, and MOSA really, that's going to be a game changer. When you can see through your night vision system as the soldier going to the ground, you know what it looks like as you're landing. You're not hitting the ground trying to figure out where that gunfire is actually coming from. You're getting update on your soldier systems of current operating picture. And I think about my son, who's an infantry officer in the Army, and what capability him and his soldiers will have in 10 years and then 15 years as the Army progresses with and the Joint Force. But the Army's never going to be outside of the Joint Force. The Army is a part of the Joint Force, and they're going to be in the Pacific with the rest of the Joint Force. They are right now. They have been since the beginning of the Army's and really the way DoD approaches joint operations. So it just makes the Army more capable for the Joint Force and more value to the Joint Force, because you reduce the strategic air and sea lift that's required to get the Army there.
Terry, I'd like to add to that, because this is a big thing. So by reaching out to us on this panel, and with the experience that we have, I feel very honored to work for Bell. For the idea that we know that the Army is going into a different environment. So if the Army is going to a ship, they're going to go to a Navy environment. From an airspace control perspective, and command and control, and just airspace deconfliction, when they get into certain areas, they're going to be in a Marine Corps environment, or they're going to be in an Air Force environment. So rarely does the Army go into an Army environment. And so we know that, and so let's help advise the engineers, let's help advise the technical experts within the talent within Bell. Just the short time that I've worked with Bell, I've witnessed the immense talent at the engineering level, that they can understand what we're speaking of, but we do have to speak it within that type of environment. And if the Army is reliant on other services, then let's make sure that the Army's compatible. And having been in environments where could not speak to the Marine controller or the Navy controller, it's frustrating. In fact,
Yeah.
it's almost a mission cancel.
Yeah, you know, I think when I think about the Joint Force and I think about how the Army operates as a part of the Joint Force, I think one of the things that is so important and why these programs are driving to the 2030 objective is because they need the ability to have overmatch, and they need the ability to demonstrate that openly to adversaries around the world, because that's how you deter. You don't deter by saying, don't do that. You deter by demonstrating the capability to compel action, and that's what I look forward to seeing with the fielding of FEL, especially the long-range assault.
Let's go back to the air vehicle for a minute and talk JMRTD. So JMRTD started in 2013. In 2017, we first flew the V-280 Valor, which was our clean sheet demonstrator, again, for the Army Air Assault mission. We were able to fly over 214 hours. We were able to fly with 5 U.S. Army experimental pilots over 15 sorties, and we were able to capture over 2,200 test points. In that time, we demonstrated 305 knots, true airspeed and level flight. We demonstrated level 1 attitude quickness in terms of low speed agility. We also demonstrated the ability to sling load and deploy a fast rope and incorporate rapidly mission systems. Talk about, if we can, some of the things we were able to demonstrate, sling load, for example, and what that might mean for a future vertical lift aircraft.
I would like to jump on that one. Having been a Chinook aviator for the majority of my career, sling load is a very limiting mission. That is not a primary mission, even from an air assault standpoint. External load is something that is necessary. But if you look in a multi-service sling load manual, there are speed restrictions for every load. If it's more aerodynamic, the slower it is. You would think, having flown the heaviest aircraft in the fleet and have hauled up to 18, 19,000 pound loads, you're still only flying 100 knots at the max, at max. So your fuel burn rate, and you get into the base. So if you advertise that this aircraft is going to be your sling load as a primary role, you just now put the existing fleet back on top again. It will be able to sling load, so there's always going to be that ability. The Army wants to sling things from point A to point B, but if you're looking at a primary role, speed is just not there. You won't be able to achieve it. So I think that's a losing conversation if we jump into that sling load is going to be the primary role of this aircraft. And the reason I say that is the aircraft needs to have that ability to be efficient, and efficient is up at high speeds.
Thanks, Doug.
Ryan, you touched on earlier, and you just talked about some of the attributes of JMRTD, but one obvious thing is that this airframe design is standing on the shoulders of 600,000 hours of flying. So this technology, we've learned a lot from V-22. We've designed out a lot of the challenges that existed in terms of maintenance and so forth on that airframe, and we're now ready to move forward with what is a clean sheet design that's informed by everything we learned since the 1980s on V-22. It's proven technology. We're not asking, nobody's making a leap here into the unknown. So we've taken a real good thing and made it better, made it perform better, made it more agile. That is something that the Army can look to and say, okay, this is a safe bet. We know this is going to work.
No, that's great, Jay. Let me ask for Jay and Randy, you guys have spent a lot of time with the engineers. What is the Army sacrificing with the V-280 to get the high speed and long range capability?
Not only has Bell learned, the DoD as a whole has learned what tilt rotor can bring to the fight. The Marine Corps, Air Force, and Navy already have V-22s. The Army's ability to not only operate in that joint environment with common type airframe, to take advantage of the tactics and techniques that are already proven and in the field is going to enhance how quickly the Army is going to be able to transition with this aircraft.
And something else, and I think Doug mentioned this earlier, but complexity is a problem. So anytime you can drive complexity out of a design, what are you doing? Well, you're making it easier to manufacture. That drives down cost right from the get-go. But when you take complexity out of an airframe, you increase reliability. Core reliability is how you do multi-domain operations. It's how you put aircraft forward in a distributed environment and you escape that much of that maintenance burden. So simplify a design, that's what we've got. We've driven out that complexity. When I look at some of the other designs that are out there, they are incredibly complex, and I wonder, what is the bill once that aircraft crosses over the DD-250 line and enters out in that unit is going to spend 40 years out of there. All that complexity just went with it.
Yeah.
That's going to be a problem in the future.
And so the Army learned. So their operational concept team was so focused on the agility, the control laws, and handling characteristics, they moved on. As soon as they realized that any airframe that's ground up built with today's technology, it's solved right off the bat. So really it came into then that complexity. And when you start evaluating what is going to be a cost driver, what are those things that is going to be complex, is rotor blades. Mm-hmm. And Bell has done a fantastic and phenomenal job of building robust rotor blades, whether it be the V-22 or a Marine Corps aircraft. And rotor blades is the cost driver, and it's also the sustainment trail from an operational standpoint that has grounded fleets in the past because of rotor blades. And let's not do that. Let's not do that. Let's keep what we have in our proven technology. The one thing for the, when you talk about mission compatibility, we demonstrated that we can fly fast, we can fly far, we can fly very far. Mm-hmm. When you could fly from Fort Campbell to the National Training Center at Fort Irwin unrefueled, that's amazing. And so when you get into those aspects, so we proved the capability, we've proven the airframe capability. Now is the time, and I'm excited to start putting some mission enhancement and capabilities on there, fast ropes, hoist, the litters, all those things. The time is now to do that, and I'm excited for Bell that is the stage now, and I'm excited for the Army.
Yeah, they'll be able to train Joint Force Entry into JRTC from Fort Campbell. So you can load the aircraft, load the battalion of aircraft at Fort Campbell, fly the soldiers to JRTC and do a Joint Force Entry training event on day one of landing at the training center on one tank of gas. Now, that's going to change how we train the Army. It's going to change how we think about the capability of the Army. And I'm so excited to see what they come up with and how they change their tactics and and how they change the doctrine to take advantage of the capability. I think about the M1 capabilities over the 60. It's a much different size tank, much different capability tank. Well, that's what you're getting with FVL and Future Long Range Assault. You're getting a much different capability. The good news is you can still land 8 of these in a single soccer field, and you can land 8 60s in a single soccer field. So they are getting a larger aircraft regardless of what they select. But it's still going to be size form for that utility mission that you've heard these gentlemen talk about.
No, I appreciate that.
I would like to, put the humor into it as well. I mean, I flew the flying school bus, and really there is size suitability. And when you get into a Black Hawk, a Black Hawk footprint is the same size as this. So the Army, it's not going to change the parking spaces, the requirements for the Type 1, Type 2 type of parking. So all those things are going to be an advantage to the Army, that they could easily adopt this airframe.
No, that's great, and how the V-280 might fit alongside the current fleet. We stopped flying the V-280 after more than 3 years, and again, more than 214 flight hours. And we've started to look a little bit closer at the airframe and do some inspections of some critical components so that we can roll those lessons learned again into our future designs. Jay, what have we learned? Any insights from that activity?
So one thing right off the bat in terms of lessons learned, and again going back to the simplicity of the aircraft, is in the design, we removed the gearbox on the wing. Well, why we went with a straight wing design, and so that eliminated weight and again brought some simplicity out, designing out that complexity. But the other thing is, after all that time we build JMRTD. We run all that flight testing over 3 years, over 214 hours. We had the same gearboxes in the aircraft. The design on the yoke on the aircraft, which a typical Army aviator might compare to the main rotor head on the aircraft, vastly more simple. Hey, we finished up all that testing with the same stuff in place. Okay, so it didn't have to be removed. It was proven. That's great stuff.
And so if we do have to remove a component and do some field maintenance, I know we spent a lot of time with the maintainers and the engineers trying to make sure we've optimized the design. How do you do significant maintenance in a field environment on the V280?
So, I'm glad you brought that up. So one of the things we did is we finished up the program. We're looking at, okay, if we have V280 out there on the flight line, what does that mean to the Army in terms of ground support equipment? Well, there's a good news story here. Back in the 1990s, we had something called the SCAMP, and it was how we moved heavy, large components on and off aircraft, whether they're blades, transmissions, what have you. Aft pylon off of a Chinook. It took a SCAMP to make that happen. The problem was that SCAMP was very large, very heavy, and as a person that did a lot of C-17 and C-5 loading, I can tell you it was necessary, but it was evil because that thing weighed a lot and you had to fit it on the load. You just didn't have a choice. So in the 90s, we recognized, hey, we need something, the Army needed something better than that, and they started looking at other options. By the time I was in Afghanistan in 02, 03, spider cranes started showing up. The Army now has adopted SCAMP 2. It's basically a spider crane will fit in the back of a Chinook, but guess what else it'll do? It'll do everything it needs to do for the V280. So as we decommissioned V280, moved the prop rotor gearbox, blades, all that stuff, not a problem. All done inside the hangar with existing Army GSC. That's a good news story. It's a way the Army is moving forward with its GSC, and it works just fine for us.
Thanks,
One of the things that we talked about maintaining the aircraft and the simplicity of the design. I think about how we do maintenance in the Army right now, and I watch our maintainers with these really thick maintenance test flight checklists that have all of these procedures, and the amount of effort that the Army has to put into building the experience like Jay has in being a maintenance test pilot. And I think about what a health-aware aircraft and a digital backbone that has the power it needs, that it can diagnose issues and tell you what's wrong with it before you see the failure. Mm-hmm. And then I think about how the Army trains maintenance test pilots right now, and then how they're going to be able to train them in the future, and what we can get done via a line pilot doing a check versus a maintenance test pilot required for everything.
Yeah, we have the opportunity here to really streamline those operations. So when you're operating forward in that distributed environment, one of the things we found out in the last 20 years of fighting in Afghanistan and Iraq is, what are you always short of? You're short of maintenance test pilots, the one guy that can do all those tasks. Well, if we have a health-aware aircraft, some of those tasks the aircraft can do itself. A lot of the other tasks we can do with regular pilots, and then we leave the most challenging things and limit the scope of those to the maintenance test pilots. What does that mean for the commander? It means his aircraft spend less time down and he's less time looking for critical folks to get a job done in a distributed environment. We eliminate that.
Going back to the air vehicle for a minute, we talked about the efficiency of the tilt rotor and how it can fly very fast, it can fly very far, it flies with all the smoothness of a turboprop. But when people think that, a lot of times they think about 10,000 feet, 12,000 feet altitude. For the Army, it's very important to go low and fast. Can you talk about, Randy, how the tilt rotor enables you to go low and fast as well as high and fast?
Yeah, absolutely. So I agree with you. The ability to go low and fast, I think, is very important. And the efficiency of the wing in high-speed flight, and the maneuverability the aircraft is going to have, and the stability is so important at those low altitudes, at those speeds. So I think a winged aircraft is going to be much safer and efficient at low altitude, high speed, versus what we were used to in our legacy aircraft, where we considered extremely low altitudes 120 knots fast. I think that's going to change, and again, having a technology where other services have already proven out some of the techniques and tactics associated with that is extremely important.
And Doug, for mission planning, how important is it to be able to have different options like high altitude, low altitude, and high speed?
Well, that's the culture that the Army will adopt. Having flown, over 20,000 feet in a helicopter, it's very uncomfortable. One from an oxygen standpoint and one from a stability standpoint. You just can't get a rotorcraft aircraft at high altitudes and have the stability and have the speed. So the higher you go, and if you don't have a wing, the higher you go, the slower you're going to go. So it's just physics. And so one thing that impressed me about our design is that the higher you go, the more efficient you are. And so having an awful lot of fixed wing experience and Army rated in C-12, I thought truing out at 290 knots was phenomenally fast, which it is, but ours is even faster than that. And so when those things start entering, if you ask a fixed wing community for high altitude and speed, they're going to say it's everything.
Mm-hmm. And Ryan, one of the things we've had the fortune to do out at our Advanced Vertical Lift Center, we've brought in several W5s, and we've been able to fly them in our simulator, which has the same control laws that we use in the aircraft itself. And one maneuver that I really enjoy, and that really gets the point across to Army aviators, is moving low level at high speed and in airplane mode, and then making that conversion and getting on the ground quickly, and the speed with which that aircraft accelerates and then decelerates to get in and execute that landing is stunning. And the other thing is, when you're coming in, for those that have had the opportunity to see this thing fly and hear it, one of the things we do is come up on folks in airplane mode, low level at high speed, and you have very little time to hear that aircraft. When you can get in close to the objective and make that rapid transition back into vertical flight and put it on the ground, essentially unannounced from long distance away, that having aviators see that and having aviators experience that, it's an eye-opener.
And I think low level doesn't mean low altitude.
Yeah.
So the climb capability of this aircraft,
right,
to get over mountain ranges and things like that, even if I maintain that low altitude or low level flight, is important as well. It opens up a larger portion of the Earth than we currently have in a lot of our rotor wing fleet today.
And the ability to self-deploy is icing on the cake. And if you can get from the continental United States or maneuver from one area inside of a theater to another area by yourself and then meet up with the force, that really adds to the capability of not only the Army but the Joint Force.
That's an absolutely great point, and that is when something kicks off, right now the Army is depending on others to get it moved somewhere, and that's a bottleneck. So, imagine we have a situation where we got to move a whole bunch of folks somewhere. If you're dependent on Strat Air, you have a bottleneck. Well, your other option is to put them on ships, but that's going to take 30 or 40 days to execute, rebuild, unload, and all that. So now you're not relevant. Well, if you can get there yourself quickly, avoid the bottleneck, and remain relevant, that means you stay in the game.
And a fly-by-wire aircraft will allow the Army to take advantage of artificial intelligence and the ability to autonomously maneuver move the aircraft without humans in it. We move unmanned aircraft around the world today without a human in the aircraft. Global Hawk, just for one example. So you could take advantage of that fly-by-wire technology and the digital backbone to move the aircraft inter-theater or intra-theater by itself to link up with the crews to do the mission. And the thing about flying on a wing and flying at 240 knots, you are going to get there faster, and that speed reduces the O&M, the operational and sustainment trail, not only cost-wise over flight hours, but cost-wise as in how much maintenance you have to do. So if it takes you 20 hours to get, from Hawaii to the Philippines, that's minuscule amount of hours when it talks to maintenance compared to what you would have today if you had to move an aircraft at 120 knots that distance.
That is a good point. I mean, when you go twice as fast to execute a mission, you're now using half as many flight hours. So that's an interesting thought when it comes to maintenance and affordability of the aircraft platform, in general.
Yeah, the cost per flight hour. Well, what did you move in that hour? You've gone a lot further. So that fundamentally, it almost questions whether or not that's a good metric anymore. But let's leave that alone. That we're still going to have cost per flight hour, but you're going to get a lot more done in that hour.
Absolutely. So we talk about the Army is relying on the Army and how the Army relies on other services. Well, the services rely on the Army too. And so if you go to every combatant commander or you go to every crisis response force that's regionally aligned, the only way that they can respond to embassies, they can respond to U.S. Citizens that are captured, to get it in there for a vertical lift capability is a Marine Air Ground Task Force or the Army. So whoever can get there easily, the quickest, have the most combat power on there. You could look and you could dissect historically failed missions that have happened in the Mediterranean, in the Pacific, and it was operational reach. Every one of those operational reach. So those crisis response forces are looking for something to get them there quickly, efficiently, and get them out vertically. And right now, that is something that we could fill the gap. We could absolutely fill the gap.
We talk a lot about direct costs too, the flying hour costs. What we don't talk a lot about is the indirect costs. Just something as simple as an admin move from Fort Campbell to NTC requires a lot of logistics for not just the flight there, but the RON, the remain overnight that they're going to have somewhere, and the rental cars or buses and lodging and food, just to get a battalion move from Fort Campbell to NTC, and that's in an admin stateside environment. You convert that mission into a tactical mission. Now I add risk because that same logistics point is a risk to the ground force. I need security, I need fuel, I need ammo to get rid of that middle indirect cost is going to be important for the Army.
Yeah, any thoughts on the elimination of FARPs for long-range assault aircraft?
Well, that's survivability, and it's really, we talk about survivability in the aircraft and the air crew, but we don't talk about, generally, we don't talk about the collective survivability that comes with removing a FARP. I mean, the cost to put the FARP there, the personnel that have to secure the FARP and operate the FARP, that's all risk, and that's all survivability challenges for a Army Division Corps or a Joint Task Force commander. And you take that out of an air assault, you now change the calculus for that operational command on whether they can or cannot, or will not do that mission. And then now what you have is the last piece of the Army's MDO.
I don't know any ground force commander, we're going to do this one mission. Well, there's an iterative effect here. Army doesn't go out and do something one time. It gets into an area and does missions over and over again. And if you look at the iterative effect of the amount of fuel we can save, the risk that we take out of all those missions, that really adds up. If you have to go somewhere and do something for 30, 40 days, 6 months, whatever, I don't know any commander that would look at that and go, well, I'm not really concerned about fuel or risk to my soldiers. Of course they are. And you eliminate all that during those 30, 40 days, 6 months, whatever it is.
Yeah, and if you look at it just on the assaulting force perspective, they don't just carry soldiers with their packs. They carry, mortar plates and extra ammunition, and they're carrying Dragon, anti-tank guided rockets. They carry a lot of stuff besides just the assault force. And the extra payload that you get with future long-range assault, specifically the V-280, you can carry a squad and the squad stuff with them to the objective, and whether it's the X, Y, Z offset, whatever you want to call it, you can carry them to that point and get them there efficiently, effectively, and be as agile as you need to be.
And as one of the co-authors of the X term, I could actually claim that I was one of the co-authors of naming it X, Y, and Z. That was just a term just so we could simplify how far we were away from the objective.
Exactly.
That's it. Maneuverability in the objective area is really what we should be focusing on. But back to the FARP issue, I think the current fleet for decades is going to require FARPs across both a mature and an immature operational environment. But the low density medevac capability in a mature environment is sometimes a minimum force for a mission. There are patrols that will not go outside the wire unless they have medevac ability. And so we have a low density airframe, like a medevac unit or medevac aircraft, they can only go so far so fast. So that golden hour is now going to be reframed. It is already reframed with the CV and MV-22 fleets providing casualty evacuation and medical evacuation capability. It's immense. So if you get into different theater of operations when there are V-22s, it's a game changer. It is already a game changer, and it's witnessed across. So that's more experience that we are able to capitalize at Bell to know that that is a force multiplier. And as soon as they came into theater, the V-22s, whether it be MVs or CV-22s, unbelievable. The ground force will not object to the idea that speed is everything when it comes to saving lives.
Well, not just saving their life, but saving their quality of life, because if you can get them to a roll 2 or roll 3 or a burn center faster, you may not just save that soldier's life, you may save that soldier's quality of life, and they may never get to put the uniform back on again, but they can go home to their family and still feel whole, or some sort of whole that they couldn't have felt if you didn't have FEL.
And I don't want to get emotional because I normally do, but I have had numerous soldiers expire in the back of my aircraft because I couldn't fly fast enough. And I thought flying 160, 170 knots was as absolute fast as I can go, and it still wasn't fast enough.
You know, we talk, when we start talking about medevac and stuff, you know, there's another piece of this, even in continental US. If we need to do something and you have that kind of range like you would have on 280, let's say you're responding to something like Katrina or an event like that. The 280, one, you can get people to that next level of care. Two, instead of moving people from their immediate danger to somewhere that's slightly less danger, and now you've created yet another problem, or you're trying to put them in a stadium. Hey, how about you're able to move them completely out of the area? They don't have problems getting fuel because you have increased the area that you can respond from, and you eliminate a lot of the other logistics problems because you're able to reach out to areas that weren't affected by the fire, the hurricane, whatever, the earthquake, whatever it was.
Or assisting our partner nations. I mean, in their catastrophes, the ability, some of the, India is a gigantic country. The ability to provide aid is extremely important to the U.S. in support of our allies. Yeah,
the Army does so much more than just fight.
Well, humanitarian, I mean, peacekeeping, all the village stability is a big one. So I had a good conversation with Tennessee and Kentucky National Guard, the fires there in Gatlinburg. How would they employ the V-280? One is time and the logistical footprint. So once you get there, to put a Bambi bucket underneath to put out fires, once you get there, then perform that mission, but you'll be able to efficiently get back out of there without having to have something in and around in that area. It's amazing where the cost is reduced from an operational perspective because of the efficiencies at cruise.
Yeah.
So Jay, it's so easy to educate once you get your mindset around the matter of time. If time is within 1 hour, you can do the same things you did, but you just now put your footprint out double of what it was before in the same time and space. Now your space is out in the same time. It's amazing how the capability just is immensely growing.
One of the things I most look forward to is watching the CW2 and CW3 get this technology in their hands and develop the tactics, techniques, and procedures that are going to be used in order to make the Army better and more agile and more capable in the future. And because that's who's going to figure it out, and they're going to come up with things that we can't think of right now because we've never flown it operationally. Mm-hmm. It's so much capability that I believe that they're going to find new and better ways to do the missions that they do today.
No, that's great. Thank you for that. Gentlemen, we're incredibly lucky at Bell to have your talent as part of the Bell team. Why did you pick Bell?
I'll back that up about 3 or 4 years. I had the unique opportunity to evaluate the designs. When there were 4 designs in the competition, I had the experience to even train other aviators from different services on the designs, whether it be academically or whether it be in a full motion simulator, and gravitated to the wing, gravitated to the V280 tilt rotor technology. So it's a very fine line between vehicle, technology, and culture. And so the culture within Bell is something that is what I have been striving to achieve in my whole military career. The Army has its unique culture. I also had the unique opportunity to be with the Director of Talent Management for the entire Army. And that's where we would work in the Pentagon, and I was looking at really where the talent resides within the Army. I see that talent that resides at all levels within Bell. It is exhilarating to know that I can now support the warfighters in the future in this role. I've had opportunities to look at different career paths to support the warfighter, but this here is the most exciting and the most rewarding to make sure that our warfighters have the best technology. And I've had a comparison of across the level from different manufacturers, different airframes, different types of technology, and I am very honored to work for Bell.
You know, the reason I chose Bell was being the FVL guy for SOCOM. I had the opportunity to go to all the vendors that were participating in JMR. And I think one of the things that impressed me most at Bell was, one, we had a lot of younger, invigorated engineers that wanted to solve tomorrow's problem, not the way we did it yesterday. I was very impressed with that. Two, being a longtime maintainer like Jay, I saw just something as simple as how we built the aircraft using the digital thread, and it was almost IEDM ready, and you were just building the aircraft at the time when we visited Amarillo. So there were a lot of things that just absolutely led me to Bell. I was tired of the companies that were telling me, yeah, I know you want that. You think you want that. Here's what you really want. And Bell wasn't doing that.
Yeah, I think too, I retired out of the Pentagon, and my last 8 years in the Army, every day I woke up and tried to figure out how we could change the way we do things today, the way we train pilots today, the way we look at our policies, and how do we make it better to make the Army more efficient and more capable. And whether it's how we make pilots in command, or how we assign people to organizations, and how we manage that talent once they're in the organization, but also how do we look at overarching policy for the Army aviation, and make the Army a more efficient and better force because of it. And when I came out of the Army, that was the first thing I noticed about Bell, is that they were looking very similar. How do we change? How do we continue to innovate in the aerospace industry? How do we continue to find a better way to do what we do today and challenge ourselves every day? And that culture drove me right to this organization.
I had a similar experience in fact, all three, Doug and Terry and I were all in the Pentagon, overlapping times. And I had a discussion with Jeff Slosher, and he said, "Hey, you ought to think about Bell." And during that time, I also had a conversation with Frank Lazaro, somebody I have a lot of respect for, that Army Aviator, also a special operations aviator with the Air Force, and you know, Jeff Slosher made the point that, hey, you have a unique opportunity here, once in 40-year opportunity, and the time is lining up to modernize, help modernize the United States Army from an aviation standpoint. These types of opportunities don't come along very often. So, you know, to Doug's point, hey, what a unique opportunity and an ability to move the Army forward. And I think Bell's well positioned to do that. It's got the right people that understand the problems and the challenges and see the potential there.
Yeah, for me, probably the first thing was opportunity. Coming out of my last job in the Army as the ASDAT team chief, which is the Army element of the Joint Combat Assessment Team, where we actually investigated combat damage in aircraft, whether an aircraft just got a couple holes in it or got shot down, and all that information gets collected, put into a joint database to learn from those lessons. Mm-hmm. And I kind of coined a phrase that as that we try to do operational support from a warfighter perspective, and that's what we're doing here. We're working with engineers. We're giving them operational relevance to what they're doing, helping them understand the mission set, and just having the opportunity to kind of still do the same thing, to take a great design, mm-hmm. give them, help them understand the mission, and take all the knowledge they have to make the system better, to be more operationally relevant is a great opportunity. And then the culture. I think Bell is team-oriented. I think they're results-oriented, and a good example of that is just really the COVID stuff, how we, and like everybody else, we transitioned to using Microsoft Teams, and Bell was more focused on results than other people I know or other companies that they were more worried about punching the time clock. What are you doing at home? But Bell was really focused on results, and I think they did a great job of doing that distance collaboration, still tying operators in with the engineers and moving the programs forward. The simple things like the dress for the day. I mean, that's treat it like an adult. You know who you're meeting with today, so you dress appropriately. And the other big thing, watching Mitch actually his one of his videos, I believe what he says. Where some other CEOs, it's like they're reading from a billboard. And I think that that culture kind of permeates through Bell, and actually people believe it. And I think it's been a paradigm shift, from maybe Bell of old to where we are today. And I love organizational culture, and I'm just happy, and I feel very fortunate to continue to do the stuff I kind of did in the Army, because it was kind of culminating mm-hmm. between some of my experiences. It's like I did the Army stuff, education, both Army and civilian, some other opportunities to where I've been training my whole life for the job I'm in today. So just a great opportunity. I'm just happy to be here.
Till I got next to an engineer and started talking through the operational aspect of why and learning the physics aspect of why, you get the combination of our knowledges, which makes the product better, versus the intersection of our knowledge, which doesn't help us get better and make a better solution.
I'm still learning. Mm-hmm. And I think when you think you know everything, that's when you need to hang it up. So to have a job to where I continue to learn, and I dig into like the mill specs and mill details to go, hey, what is the requirement? Army gives us a requirement in our spec, right? But then that all points to different references, and what does that mean? And then translating that to the engineers. So we do it, we'll just get the DoD way. Mm-hmm. We're not making it up as we go along. So to have the ability to kind of provide the input is tremendous.
Gentlemen, thank you so much for your service, your experience, your time on this panel, and the great discussions. Thank you so much for watching.